All right, greetings YouTube, Beautiful Mind here, and we are moving into chapter 5 for trigonometry on applications of trigonometric functions. Let's see. And so we started with section 5.1, the laws of sines and the laws of cosines. A few objectives. 1, learn vocabulary and conventions for solving triangles. 2, use the law of sines. 3, use the law of cosines. So first we have the law of sines. The following diagram illustrates the law of sines, all right? So let's look here. Okay, so angle B is acute right here. So acute meaning less than 90. Okay, so we have triangle A, B, C. Opposite of each angle is its corresponding side, right? So we have this angle A. Opposite angle A is side A. Opposite angle B is side B. Opposite angle C is side C. This H is the altitude or the height of our triangle. I think D is this point here, right? So then we have this segment AD and we have this segment DB. Okay. Let me see. So main takeaway here, we want to note that angle B is acute, so less than 90 degrees here. And then in this other example, it's still triangle ABC, but in this case, angle B is obtuse, which is larger than 90 degrees, okay? And so notice the position. Notice that here D is between A and B. Over here, D is to the right, okay? Let's see how this unfolds. So in any triangle ABC with sides and length A, B, and lowercase a, B, and C, the sine of A over A equals the sine of angle B over B. And then the sine of angle B over B equals the sine of C over C. And the sine of C over C equals the sine of A over A. Okay. So we can write these relations in compact notation. The sine of A over A equals the sine of B over B equals the sine of C over C. That's fine. And then the reciprocal is true as well. So then A over sine A equals B over sine B equals C over sine C. Okay. So two triangles at play here. When angle B, so just usually when I'm doing my triangles, I'll just do my triangle A, B, and C like this. If we got identify, if angle B is either acute or obtuse, that'll help with the positioning. And then we just fill in our labels. We decide which kind of triangle are we working with, or we're going to work where angle B is acute, or we're going to be working with angle B is obtuse. And then, we see, can we apply the law of sines? Okay, so let's see if we can see this in action. So here we're asked to solve triangle ABC, where A is 62 degrees, B is 74, right? So that's the first case where angle B is less than 90. I round the side lengths to the nearest tenth. Okay. So usually I would like to start with a triangle. Namely, I'm going to do something like this. Not necessarily a right triangle, but we have that our angle B is acute. Okay. So I'm going to label this as my angle A, my angle B, my angle C, sorry. Backtrack. It goes like this. A, my angle B is here, my angle C. Opposite angle A is side A. Opposite angle B is side B. Opposite angle C is side C. Okay, I'll put it like this. Based on the law of sines, we hadn't really used our H or our D just yet. So I'm going to hold off on the H and the D for now. Okay, so now we're given that angle A is 62 degrees. So I'll put my 62 degrees here for angle A. Angle B is 74 degrees. Okay. So we'll calculate for angle C momentarily. And then side C is 14 feet. Okay. So again, the law of sines, we can use the sine of A over A, sine of B over B equals the sine of C over C, okay? Now, the interior angles of a triangle should add up to 180. So then to solve for angle C, we can say 180 minus 62 minus 74. Hey, Google, what's 180 minus 62 minus 74?
180 minus 62 minus 74 equals 44.
So angle C should be 44 degrees. I'm doing that in another color so that, in case we made a mistake there, we'll know that was something that we introduced, right? Okay. So it says solve for the triangle. So in order to solve for the triangle, we want to find all the parts, find all angles and all side lengths. So then we have angle C with side C. In order to find side A, I'm going to use the law of cosines in the following manner. Let me see. So I'm going to do the sine of 62 degrees under side A should equal the sine of 44 degrees under side C, which is 14 feet. Okay. So then, long story short, side A should equal 14 times the sine of 62 degrees over the sine of 44 degrees. Okay. Now, when we go to use our calculator, we need to make sure that our mode is set to degrees. Let's see. See if I can get this calculator to open. Okay, let's close tabs. It's right here. Okay. Reload and refresh. Okay. So let's go to mode, change from radians to degrees. Okay. Again, so we want to solve for A. That's going to be, let's do open parentheses, 14 times the sine of 62 degrees, close off the numerator, divided by the sine of 44. Okay. Round to the nearest 10. So we get approximately 17.8 feet for side A. $17.8 feet. I'm just going to highlight our result like this for that one. Okay. So then let's see. So for A, we got 17.8. And I'm just going to do this real quick. Okay, so we got that for side A. And it was basically a similar thing for side B. Let me see. We're going to have B over sine of B equals 14 over sine of C. So then long story short, it's done in a similar fashion. I'm just running out of space. So B should be 14 times the sine of angle B. So the sine is 74 degrees over the sine of 44. So when we're doing these calculations, whenever possible, we want to try to use or prioritize the given information over the calculated information, just in the off chance that we made a mistake in our calculation. So I think that we don't have a choice in using the 44, but that's a low risk of making a mistake there. But yeah, just whenever possible, we try to prioritize the given information when we're doing our calculations over our calculated information. In case, because we don't want to base our result on an error, because then everything beyond that is going to be more and more skewed. Okay. So here, I think everything is the same, except instead of 62, that's a 74. So 19.4 feet, 19.4 feet. Okay, so we got 44 degrees, 17.8 feet, and 19.4 feet. One thing that you could do here quickly to just confirm, or, confirm isn't 100% correct here, but it kind of supports our claim, right? The largest side should be opposite the largest angle, and it is. The smallest side should be opposite the smallest angle, and the middle side should be opposite the middle angle, okay? So then 44, we got that. So we got our angles. We use the law of sines to find A and B. Okay, and I think we got those results. 17.8. Okay, yeah, we're good. So they essentially did the same thing that we did, okay? Okay, so the height of a mountain. From a point on a level plane at the foot of a mountain, a surveyor finds the angle of elevation of the peak of the mountain to be 20 degrees. She walks 3465 meters closer on a direct line between the first point and the base of the mountain and finds the angle of elevation to be 23 degrees, right? So now it looks like we're going to be working with like a triangle where our angle B is going to be obtuse, right? We'll see it in action. We'll see it momentarily. Estimate the height of the mountain to the nearest meter, right? So I think we have a picture. I'm just going to use my picture. So we have our first point, and she gets the angle of elevation to be 20 degrees. She walks 3465 meters in a direct straight line towards the point along the straight line of sight. And then she gets the angle of elevation to be 23 degrees. All right. So then we find the supplementary angle to 23 to be the 157. That 157 degrees is why I was like, okay, we're working with an obtuse triangle. All right. So it says estimate the height. So we want to find H. Okay. Let me think about this. All right, so we can use the law of sines to find B, right? Let me think. Okay. All right, so we got a couple of triangles at play here, right? So let's see what we can do. So angle A is 20, right? We can use the law of sines to find this guy. All right, we can solve for B. Let's see. So then we'll have B. We'll have a 20. All right. Sine opposite over hypotenuse. So if we did, so once we solve for B, if we took the sine of 20 degrees, that should be what? Opposite over hypotenuse. So then H should be B times the sine of 20 in this context, all right? So let's see if that works. Okay, angle C, that's fine. Yeah, let's see if that works, all right? That should work. So let's use the law of sines to solve for side B. If we did B over sine of B, right? Equals what? What's the other one that we have? It looks like we have C over the sine of C. All right. Okay. So we're trying to solve for side B. So we can do B over the sine of, let's try B and let's do like this. We'll try B over the sine of B equal to, let me see, B over the sine of B. We have this side down here, which corresponds to side C, right? So then let's do B over sine of B equal to C over the sine of C. Let's see if that works. Let's just see. C over the sine of C, okay? We're trying to solve for B, so then ultimately B should be equal to, now our C, lowercase c, is going to be that 3465 meters. Okay. The sine of angle B, so times the sine. Now angle B is 157 degrees. Okay. Over the sine of angle C is 3 degrees. So that's going to be the sine of 3 degrees. Okay. So now we have, I'm just going to leave it like that for right now. We have an expression for side B, right? And we want H. So we have the 20 degrees. We have the side B. We want to find H. So if we took the sine of 20 degrees, that should be opposite over hypotenuse. Okay. So I'll continue working here. If we did the sine of 20 degrees, that should be H over lowercase b, the result we get from up top. So then long story short, h should be equal to b times the sine of 20 degrees. Okay. So we could just multiply the result that we have up top by the sine of 20 degrees, and that should give us our h, our desired h, okay? So then h should be approximately, we'll probably round it to the nearest meter. So what I'm going to do, that expression we have at the top for b, I'm going to multiply it by the sine of 20, and we'll use that to find our h. Okay. So mode, I'm in my degrees, okay? So now for the numerator, we have this 3465 times the sine of 157 degrees, okay? I'm going to go ahead and say times the sine of 20 degrees, okay? So now we need to close off the numerator, and we're going to say divided by the sine of 3 degrees, okay? Let's see. So if we want the height, and if b is the hypotenuse, we would anticipate something that should be less than the 3465 meters. Uh-oh. Let me see my mode. What are we missing? The sine of 20 should be opposite over hypotenuse. So multiply by b times the sine of 20. Uh-oh. Sine, meters. Oh, okay. Okay, I think I see something. Okay, sorry. Okay, I think I found my error. So when we did C, right, that 3 degrees was for that obtuse triangle. But angle C, in the context that we were using it, is for that right triangle. So that's going to be a different angle, right? So what we need to do, we have the 90, we have the 20. We need to say 180, or really just 90 minus 20. So that angle C is really 70. Let me think about it. Okay, we found an expression for B. If we took, that's side B. So if we took the sine of 20, no. Okay, I might. Let me think about it, because we're missing something here. I mean, maybe that could be correct. Is that not? That should be the hypotenuse. I mean, this could be correct. Maybe I interpreted something incorrectly, but I think our calculations might be fine. So if we took this to the nearest meter, 8848 meters, that could be the case. Let's check. We got 8848 meters. 8848 meters. I know I said an error. Let me see, because I was thinking that this was like the hypotenuse of the larger triangle. And I guess it could be the case that this could be the hypotenuse, right? So it's not necessarily that this is the hypotenuse, but let's just see how do we do. So the 8848. Let's see, compare. Oh, I had some space, I didn't realize it. 22, 3465. They did the same thing. I don't understand why ours is getting off. Okay, triangle BCD. Yeah. Okay, we got it. Yeah, we're good. So the mountain is approximately 8848 meters high. So yeah, they did the exact same thing. So again, the work that we did was fine. I think my interpretation somewhere at some point got off a bit, but what we did was correct, right? Yeah, what we did was fine. Let's do a quick recap there. Okay. So we have this smaller triangle ABC, right? But that C is really two angles in there that we're kind of losing track of, right? So we're trying to find H. We realize that if we do the sine of 20, that should be H over B, right? So if we solve for B, then we can find H. So if we wanted to solve for B, we can use the law of sines, right? So let me see. If we did the sine of, let me see, we got this 3. Okay, so we can do the sine of 3 degrees, B over B. We're trying to solve for B. We have angle B. And then we have this 3 degrees corresponds to this 34 65. That's where essentially this guy came from using the law of sines, right? B over sine B equals C over sine C. And kind of mixing up some things here with the C. That's where the confusion is coming. Because there's really 2 angles in here. But, sometimes we're referring to the smaller one that's 3 degrees. And then in the second part, we're referring to the larger. So we should probably call those 2 different angles. So we did B over the sine of B, right? Over the sine of 157 equals C, which is this 34 65, over the sine of C over the sine of 30, right? So then ultimately B was this guy. And then I just left it as is. So if this is equal to B, when we take the sine of 20 for the larger triangle, that's going to be opposite over hypotenuse. So then that gives us that sine of 20 is opposite over hypotenuse. So then H equals B sine 20. Then I just took my result here times the sine of 20 to get this guy. Okay. So yeah. All right. That was an adventure. Let's try another one. Let's see what else we got. Come on. I guess I can delete this page since we used the previous one. Okay. Oh, maybe that was a hypotenuse. Oh, they did A. Yeah, we're fine. Anywho. Now they solved for A. I mean, it's essentially the same thing. They just used other information. We got the same result. Okay, let's keep going. Let's try another one. Okay, so now we have this ambiguous case. So we started with like 2 different cases, right? Where angle B was acute. That was like the first one we worked. And then we did another where angle B was obtuse. And then, we kind of worked that one. So there's an ambiguous case that arises when we're working side-side angle, right? So let's see it. If we know the lengths of 2 sides of a triangle and the measure of the angle opposite of one of these sides, we have a result that is not a we can have a result that's one of the following. It can either be not a triangle, one triangle, or 2 different triangles, right? So it's an ambiguous case, and we'll walk through how to process the ambiguous case. For this reason, case 2 for the SSA or the side-side angle triangles is called the ambiguous case, right? I think they intentionally put SSA because obviously you could put the reverse, and then that's how I remember it because it's kind of pain in the butt, right? But instead of, you don't want to put ASS, so we put SSA. So side-side angle. Once you identify that, then you have to figure out how. The first task when we were working this ambiguous case, we had to identify, okay, how many potential triangles could we be working with here? Okay, so we still kind of have like our triangle ABC. We have like A here, C is here, and then B is kind of left open. And you have to compare, like for instance, if this side A is less than our H, right? So I think we do have to find our H, all right? And we'll have some information, but if we find that side A is less than our H, then there's no triangle, okay? If side A is equal to H, right? So we still have to find the height or the altitude, then there's going to be one right triangle, okay? If side A is larger than H but less than B, then we have 2 possible triangles. Okay, because it's basically like that side A can swing and it'll connect that baseline in 2 different points at B1 and B2. So then it creates 2 different triangles that we can work. Triangle AB1C and then triangle AB2C. So one obtuse and one acute. And then if side A is larger than side B, then there's only one triangle there. Okay, so that's the ambiguous case. Let's just work a few examples to see it in action. So that's when A is acute, and then when A is obtuse, There's only two scenarios. If A is less than or equal to B, there's no triangle, right? So if this side A is less than or equal to side B, then there are no triangles because this side is not long enough to reach the base, right? And then if A is larger than B, there's just going to be one triangle possible. Okay. So again, let's just see it in action. Okay. Solve this triangle with this given information. Round each answer to the nearest tenth. Is this the ambiguous case? Okay. Let me see. We do have side angle. Okay. So if this is potentially the ambiguous case, let's see. So we have our baseline. All right. And then we have something like this. And then we have something like this. All right. Where this guy is what we need to find, right? So this will be our A. Now our A, we don't have information. Let's put our A here. This is usually what our C. Our B is somewhere over here in the mix, right? We're just going to kind of leave it for right now. It's just in that general area. We do need to find our H. If I can get that, then there it is. Let me say something here. Style. Okay. So we need to find our H. We need to find our side A. Okay. This is our side B. Our side C is going to be down here. We're going to come back to that one. This is a 90-degree angle there. Okay. Now, I think they rearranged it. Okay. So we might need to move our labels around. Because if this is our 32, so I'm going to have to move some things around. All right. This is our 32 degrees. So then that means side B has to be opposite angle B. I'm just going to move these for right now. And we're given side B is 100 feet. So then side C is 150. So that's this guy over here. If this is C over here, we got what, 150 feet. All right, let's go here. We're going to have to, we're repositioning them based on how it's given. Okay. If that's side C, that means angle C would have to be down here somewhere. It's not fully connected just yet because we have to kind of do an analysis. That means our angle A is here and our side A is down here in this general area. Okay. So side angle. All right. So the given angle goes in that position on the bottom left. Opposite the given angle is the corresponding side. And in between that angle and that side is the other given side. And we do our labels based in that fashion. Okay. So now based on this, we have our side B. We need to find our altitude. In other words, our height or our H. So we could do what? The sine of the 32 degrees would be opposite over hypotenuse. So if we did the sine of B, angle B, that's going to be H over C. So then our H is going to be C times the sine of angle B. So then H should equal C, which is the 150 feet, times the sine. Angle B is 32 degrees. Okay. So we have our side B. Let's go ahead and calculate our H. Clear mode, make sure we're in degrees. Okay. So then if we do 150 feet times the sine of 32 degrees, okay, we'll do 0.49, so 79.49. So this is approximately 79.49, should be feet, I think, are the units. Okay, so notice that H is about 80 feet, which is less than B, right? Is it more than the other one? No. So the height is 79, B is 100. So it could swing there. Is this the two cases? All right. So H, we got about 80. All right. So we know this can connect there. Can it also connect here? All right. This looks like it might be the two triangle case. The two triangle case occurs when, let me kind of confirm it. We have that our B is between, our side is between our H and our C. Okay, that would be like A is between H and B in the previous example. So right here, yes, right? Our side A is larger than H, but less than B, right? And so in this context, that works, right? So we do have two potential triangles. This side B, if it's 100, let me duplicate it. Right, it's going to hit before, because it's longer than the height or the altitude, is going to hit that baseline. So it's going to create one triangle, and then it can also create another triangle right about here. Okay. So that means that we should have two triangles. We're going to have an angle C1. Let me duplicate this guy. Okay. So we have this angle C1 and this angle C2. So we have to work these two separate triangles. Okay. So let's start off C, that's B, and there's 100. Okay. So let's start off with triangle BC1A. Okay. So let's we'll work here. Triangle BC1A. Okay. Let me see. So those parts, let's see. So I guess if we can write it like this, let's do the following. That goes there. That goes there. Okay. So we're going to work on this guy. So we have this BC1. I feel like that should be A, but that's fine. Let me see something here. That's fine. Okay, let's keep going. Okay, so now we have this, 32 degrees here. Okay. We know that this side B here is going to be 100 feet. Okay. We don't know angle C just yet, or angle A, but we know that side C equals 150 feet. Okay, 32 degrees, 100 feet. Okay, so then if we want to solve this triangle, okay. So we're given angle B and side B. So if we use the law of sines, let's go ahead and find angle C1, right? So then angle C1, okay, let's back up. So if we take the sine of angle C1 over 150 should equal the sine of 32 degrees over 100 feet, okay? So it looks like angle C1 should be the arc sine. We got this 150 times the sine of 32 degrees over 100. Okay, let's see. Let's just use our calculator. I think there's some other nuances there, but we'll catch them as they arise. Let's make sure we're at least in degrees, okay? Boom, 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 boom. Now, when we're doing arc sine or inverse sine, I know it's usually a good idea. Go ahead and identify your domain and range first. That kind of helps. When we're thinking of inverse sine, right? If we think about the original graph of sine, we have that wave pattern, right? And the original graph of sine is going to fail the horizontal line test, so we have to impose a restriction on the graph of sine so that it passes the horizontal line test. So this is just a little recap. I'll put this over here in the corner. So we put a restriction. So the domain of sine, we restrict it to where? Negative pi over 2 to pi over 2. And I think it's the closed interval. And so our y values go from -1 to 1. Then when we take the inverse, I think they switch positions. Okay. So when we get our answer, okay, instead of pi over 2, let's just write it as -90 to 90. We should get a result between -90 to 90 degrees. Okay. So I just kind of wanted to have that off to the side, okay, just as a reference. I know that comes into play, so like let's just see what happens here. Okay, so now let's crunch this number. Okay, so I'm going to do mode, make sure, okay. We're going to do the arc sine. Now on top, I'm going to open another set of parentheses. I got my 150 times the sine of 32 degrees. Close off the trig function, close off my numerator, and then I'm going to say divided by 100, and then close off my arc sine. Okay, we should get something between -90 to 90, 52.64 degrees. Okay, we'll go with that. 52.64 degrees. Okay. Now, I want to say on the left-hand side, we probably should have done C2 first, because I want to say that at 52.64, I want to say that refers to like this angle here, 52.64 degrees. I want to say this guy here is also 52.64 degrees. So then we need to find the supplementary angle. So we're going to say 180 minus that. Okay. 127.36 degrees. So 127.36 degrees. Okay, for C1. That's what we got. So we had to do 180 minus that. So we got that C1. We got a 127.36 degrees. Okay, we're going to go with that. Okay, so that's C1. So then, we can use the sum of the interior angles of a triangle should add up to 180. So we'll say 180 minus that answer, and then minus 32 to get that angle A. So we got 20.64 degrees. Okay. So maybe we should just do a table. So for triangle BC1A, I think I'm just going to do ABC1. Okay. So for angle A, we got 20.64 degrees. Angle B was given at 32 degrees. Angle C1, we got 127.36 degrees. Okay, I'm kind of out of space. I'm going to just rearrange everything momentarily. So then side A, that's going to be, I think we still need to calculate that one. We'll come back to that one. And then side B looks like it's the given 100 feet. Side C is the 150 feet. Okay. All right. So then if we need side A, in this context, we can use the law of sine. So A over sine of A equals what? B over the sine of B? Okay, so we should be able to do the sine of A times, where's my B? 100. Okay, I need to write it. I'm just short on space. Let's see. So we're doing A over the sine of A equals B over the sine of B. So then my sine of A, so I'm going to do my sine, where's my A? Right there, that 20. Oh, shoot. It would have been nice if I could have kept it, but that's fine. Let me see if I can pull the number back. We got this. Then if I backtrack, I'll get that. And then if I backtrack again. Okay. So again, we're doing A over sine of A equals B over sine of B. So I want to multiply what? The sine of that answer. And then times B. Our B is the 100 feet. Over the sine of angle B. So divided by the sine of 32 degrees. I'm assuming that it's still in degrees. I'm going to let that be. We get a side A of 66.53, I think that's feet, 66.53 feet. 66.53 feet, okay. Let's see, let me shrink, let me cut, good, okay. Let me just go here, just need a little bit of space, I'm gonna paste. Now this is just for the first triangle. Give me just a moment to rearrange these guys. So maybe the other triangle might have been a little bit easier. Cut, paste, okay. But that's the first triangle, so we still need to work on the other triangle. Okay, and I'm just gonna put this in a box with a little bit of color so we know that this is the result we got for one triangle. Okay, all right, so now that's the first triangle. Okay, so now I'm just gonna duplicate this slide if it behaves. Come on, duplicate. Okay. Boom, boom, boom. I'm gonna get rid of the stuff that I'm not using. So I'm gonna get rid of like all of this. Delete. Come on. You're not gonna work, okay. Okay, that's fine. I'll keep this as a reference. And I'll just leave it here for the time being. I wanna get rid of, okay. So I want to get rid of like all of this. Okay, delete. Okay, so now we did that obtuse triangle. That I think I just did that one first because it was like the more challenging one. At least I'm anticipating. So now we want to work on the following. This is the other triangle that we need to solve for. So like that, like this, and like this. Okay, we'll work here. Okay. So this is our B. This is still our angle A. This is our angle C2. Now we've already labeled it as the 52.64 degrees, okay? Angle B was given, so we'll do 32 degrees. If that's C, the C was given, so we can keep this, duplicate, right there. Angle B, side B is given, so we can keep this guy. Okay. So it looks like we're missing side A down here. We can find angle A. So this one doesn't seem like it has as much going on, right? Okay, so let's find that missing interior angle. So the 52, 52.4. Let's see if I can generate that number again. What is this one? Nope. Okay, 52.64. Okay. So now if we want angle A, we'll say 180 minus the 32 minus the 52. So we'll say 180 minus that answer minus 32 to get this angle. So we get 95.36. I'll do that one in purple. This one we got 95.36 degrees. Okay. And then we could use the law of sines. A over sine of A equals, so it looks like we have to use one of our calculated results. Like I don't think we can, oh wait, we can do A over the sine of A equals B over the sine of B, okay? So right here, we're going to use A over the sine of A equals B over the sine of B, because both portions or both components of B were given. So we're going to prioritize that. So then long story short, A should be equal to the sine of A, or B times the sine of A over the sine of B, right? Just multiply both sides by the sine of A, by that denominator, okay? So B was given at 100 feet, okay? Angle A, so that's going to be the sine of that 95.36 degrees. Okay. And then the sine, then divided by the sine of angle B is 32 degrees. Okay. Okay, so that 95.36, we still got that one saved? Yes, we do. Okay. So then we'll do 100 times the sine 95.36, so the sine of that answer, divided by the sine of 32 degrees. Okay. So for side A, we get that A is approximately 187.88 feet. Okay. Okay, I think that was the only missing component. I'm going to shrink these down just a bit, just to kind of free up a little bit of space. Okay, I'll just kind of put that there for the time being. Okay. So then in this case, we were finding triangle BC2A. Okay. And I'm just going to put it as A, B, and C. Okay. Angle A, we got approximately 95.36 degrees. Angle B was given at 32 degrees. Angle C2, we got approximately 52.64 degrees, okay? Side A, we got approximately 187.88 feet. Okay, that makes sense. B, we were given B to be 100 feet. And I think we were given C to be, did I calculate that? Okay, I think we're good. 150 feet. Okay. So this was the other triangle that we got. And let's go like this, like this. And then I'm just going to expand these as best I can. before I explain it, I'm going to go ahead and copy. And then, okay. So these are the results we got. So now let's compare this to our prepared notes, right? Let's just compare. I kind of want to just jump to the conclusion first. Right here. I'm going to paste. Okay. Okay, let's see. So they did BAC1. That's our guy on the left. Okay, so actually that's our guy on the right, the label. Okay. 95.4 is what we got. 32, 52.6, we got that. And then 187.9, we got that. 100 and 150. Woohoo, right? So we got the same thing there. So that one checked out. So if that one's good, the other one should be good as well. 20.6, 32, 127.4. So they just did one decimal place. That's fine. 66.4. Then we got 5.3. That's fine. Rounding, it's okay. 100 and 150. So we got both of those. We got the same result there in either case. Okay. Now let's see if we can kind of process or digest the way the textbook did it. I just want to compare and contrast to see if we notice anything. Okay. So make a chart of the 6 parts. Make a chart of the 6 parts, the known and the unknown parts, right? So we have triangle ABC. B is 32. So this has been identified as the ambiguous case, the side-side angle, right? So apply the law of sines to the two. Okay, let me see. If the sine of angle theta in step 2 is greater than 1, there is no triangle with the given measure. If the sine of theta is between 0 and 1, go to step 4. Okay. So let the sine of theta be x, where x is between 0 and 1. Then theta has 2 possible values. Okay. So there are 2 possible values. 56. So, you know, we kind of did this on our own, like in our own way, where, again, the way I kind of visualize it, you put your given angle in the left-hand corner, like the bottom left-hand portion. You put the opposite side opposite the given angle, and then you have a side between that given side and angle. And then I kind of, you have to, what I do is like, I acknowledge that hanging side can swing. So I go ahead and find my height, my altitude, and then I compare that hanging side to the altitude. And then once we can kind of get a sense of where it is or what's at play, that'll identify how many triangles we'll have and things of that nature, right? So, and it just takes a little bit of practice and exposure. They kind of go about it a little bit different way, but it's essentially the same thing. Okay. Looks like they're solving there simultaneously as well, like side by side almost. Okay, I kind of want to work another example, right? But you can see it here. I think these are not all the parts, but a good amount of the parts in the image they have on the bottom left. Oh, maybe I think those are all the missing parts. Because 100 is there. Yeah, all the parts are there. Angle A, you have 2 different angles, but that's fine. I think the label is referencing that corner. And then, you know, it's a couple of, because like if you look, oh, okay. So instead of calling it angle A, they identify it as angle BAC1, right? That's the larger one, is the 95. And then angle BAC2 is the smaller, right? So angle A is kind of referencing that position, but to get the specific angle, you do the 3 parts. You do the one corner, and then you have the vertex of the angle, and then the other corner or whatever. Okay, that's fine. So that's one thing we could have done different, but that's fine. All right, let's try this again. Let's see what else we got. So we're asked to solve this triangle given this information. Is this ambiguous case, right? Is this the one that's the pain in the butt, right? So that's going to be side angle, but it looks like a side angle. So with it being the ambiguous case, we have to identify how many triangles are at play here, okay? So now, again, the image, I kind of do the same thing every time. Well, let's just do it again. So we got this baseline, all right? We have our base. We have something coming up this way in this fashion. And then we have like this hanging chad thing. We're just going to kind of leave it for right now, okay? And then we do want to identify our altitude. So give me just a moment to kind of get that squared away. Okay, and style dashed. Okay, so now our given angle is here. This is our angle A at 50 degrees. Okay, opposite of angle A should be side A at 8 inches. So this is A equals 8 inches. Okay, and then the interior side is going to be a B in this case at 15 inches. Okay, so again we've identified this as a side angle. So that means this is an ambiguous case. So we need to figure out how many triangles are possible. Now, first thing to notice is that A is acute. A is less than 90, right? So that means that we still have that more challenging one that we got to consider. If there were obtuse, then there will only be 2 possibilities at that point. But okay, so let's keep going. So now we need to find our height, right? This guy right here. We need to solve for h here. Okay. So what we could do, right, where this is a 90 degree here. If we took the sine of 50, that would be what? H over B. So then ultimately h is going to be equal to B times the sine of A. So that's going to be 15 times the sine of 50 degrees. Okay. Mode, I am in degrees. Just want to make sure. So if we do 15 times the sine of 50, okay. So for the height, we're getting approximately, we can say 11.5 inches. Okay. So now we got this height. Now, notice that side A is 8, but our height is 11.5. So that 8 is, it's not long enough to connect on the bottom, right? So I would say that there are 0 triangles possible, right? If the height is 11.5 and this side A is only 8, is not long enough to connect and reach at the bottom. So then how many triangles possible? I would say 0 triangles possible. 0 triangles possible. And then that should be it there. Okay, so let's compare this to the prepared notes. Let's see if our conjecture is proper. Should be. Let's look at it. Come on. Okay. So we have our chart, right? Yada, yada, yada. We've identified it as an ambiguous case. So because the sine of B is larger than 1, we conclude that no triangle has the given measure. Okay, right? So 0 triangles possible. Let me backtrack real quick. I just want to see something. Back. Okay, yada, yada, yada. Okay. So apply the law of sines to 2 ratios in which 3 of the 4 quantities are known. Solve for the sine. Use the form of the law of sines, which is unknown, in the numerator. If the sine of angle theta in step 2 is greater than 1, there is no triangle with a given measure. If the sine of theta is between 0 and 1, then we proceed, right? So I'm trying to see if I can find an explanation, but what they're using is that step 3. If the sine of angle theta is larger than 1, then there's no triangle possible. If the sine of theta is between 0 and 1, then they went to step 4. Let me think about it. Anyway, but again, you saw how I did it. Like, my logic was, okay, we have our height is, we got 11.5 inches, but that side A is 8, so it's not long enough. If that side A were swinging, it's not long enough to reach the base, to reach the bottom, the baseline or whatever. So then it won't be able to connect, so then 0 triangles possible. So either one should be fine, right? You can either, compare the sine of A, or this, right? Sine of A is here, or the sine of B, I guess. If the sine of B is larger than 1, no triangles possible. Okay. All right, not too bad. Let's see what else we got. Solve this triangle given this information. Okay, is this the ambiguous case? Looks like it, right? Side angle. Okay, so first process is we're going to draw a picture. We want to identify how many triangles are possible. Okay, so we have our baseline. Okay, we got this side coming up here, some fashion like this. We got this like hanging Chad side, right? We're going to come back to that. We're just going to leave it kind of broken like that. Let's see, our given angle is C, so we're going to put that here. Okay, so then the opposite side, this lowercase c, goes here at 20 meters. Okay, let's do a better M there. Okay, and then the interior side is A at 15 meters. Okay, so now we need to find our height. Now we could do the sine thing like they did it, but this is just how I do it. Okay, let me do this real quick. Boom, 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 style dashed. Okay, and we need to find our h. Okay, so if we wanted to calculate h in this context, we can do the sine of 40 will be h over a. So then, long story short, h would be equal to 15 meters times sine is h over a. So 15 times the sine of 40 degrees. Okay. So then if we use our calculator, we are in degrees and we make sure, okay, clear. So 15 times the sine of 40, okay, we get 9 point, we'll put it as approximately 9.6. 9.6 meters. 9.6 meters. Okay, let me do this real quick. Okay, so we got a height of approximately 9.6 meters. Let me clean it up just a little bit. Okay, all right. So now, looking at this, right? Notice this side here is larger than this, and it's larger than this guy over here as well, right? It would have to be, in order for there to be two, this side C would have to be longer than H, but shorter than this side A. But because it's longer than 15, that means it's not going to connect over here. So we should only have one triangle where this guy goes to about there. Right? Okay, so it should be one triangle possible. So we'll just make a note. We'll say something like a one triangle possible. Okay. All right. So let's fill everything in. Let's see. If that's side A, that means this is angle A here. This should be angle B, and side B should be down here. Okay. So then we have angle A, B, and C for triangle ABC. And then we're going to have what? Side A, side B, and side C. Now we have what? Angle C is 40. Okay. Side C is what? 20 meters. Side A is 15 meters. Okay. Let's go ahead and try the law of sines to find angle A. Okay. So it should be the case that what? The sine of angle A divided by A, so whereas little a is 15 meters, should equal the sine of what? 40 over that 20 meters. Okay. So then that'll give us the sine of angle A is going to be 15 times the sine of 40 over 20. Okay. So again, our A should be between negative 90 to 90. In this context, that should reduce it even further to 0 to 90. Okay. So I'm just going to do the arc sine of that right-hand side. Mode, just make sure I'm in degrees. Because you don't want the calculator to be in radians and you're punching in degrees. It's not going to work, right? So let's do the arc sine. Now we have this, let's do, open the numerator, 15 times the sine of 40. Close off the trig function, close off the numerator, divided by 20. Okay, we should get something between 0 and 90. We got 28.8 degrees, okay? So we got approximately 28.8 degrees there, okay? Okay, we might have to use our calculator result. So then we can go ahead and find angle B. All right, so we'll just do 180 minus that answer minus 40. And so for angle B, obtuse, that could be the case. That seems reasonable. We got approximately 111.2 degrees, okay? So then if we use the law of sines, so then B over the sine of B, so I'm going to have this, let's do open parentheses, the sine of that answer, okay? So B over the sine of B equals, let's do C over the sine of C. So when we multiply, we're going to say, let me insert a 20 here. So 20 times the sine of angle B divided by the sine of angle C, which is 40. Okay. I think that's good. We got a little bit of extra parentheses, but that's okay. So for side B, 29 is reasonable, right? We got the largest side opposite the largest angle, so on and so on, okay? So again, for side B, we got approximately 29 meters. I knew that was going to happen, okay. Oh, most of that is in there. Okay, okay. So let me do like this. I'm going to duplicate. Oh, that made it so much worse. Okay, how can I get that? I got to isolate it. So this should be fine down here. Uh-oh. Let me just delete that. Okay, and then what I'm trying to get is that guy. Okay. I think I'll just get rid of this stuff. Delete. And get rid of this. Delete. Darn it, undo. I just, hold on, give me a second. I can use my eraser, that works too. Okay. So then, just trying to get this to behave. About like there's good. There's good. And that should be good. Shrink it down. Okay, now we got what we're looking for. Let's copy that result. Okay. All right, I feel good about this. So let's compare this to our prepared notes. I just kind of want to jump straight to the result first. Okay, and paste. Oh. one solution, right? Paste, let's see. 28, 111.2, 40, 15, 29, and 20. Right, I think our orientation was a little different, but we got the same thing, same results, okay? Let's compare this. I just want to kind of look at what they did. So make a chart, okay, we did that. Apply the law of sines, okay? So two possible values are 28.8 degrees and 151. Let's see. Since the 40 plus 151 equals 191, there is no triangle. There is only one triangle with a measure where A1 is 28.8 degrees, has a measure of 111.2, right? So then they use the law of sines. They pretty much match what we did. But again, the way I kind of process these is, that hanging Chad sign, and think about if it swings. Once I have my height and my interior side, if you think about it in terms of it swinging, that kind of gives you everything that you need to know to move forward. Okay, let's see what else we got. My battery is dwindling fast. Let me turn up the heat a little bit. Come on. Okay. So bearings. A bearing is the measure of an acute angle from due north or due south, right? So, for instance, for something like this, sometimes I might refer to this as, I feel like it's a little bit easier to process it if you say it as 40 degrees east of north, right? So if you go north first and then go 40 degrees east of that, that's the angle they're referring to. Another way you can read this is north 40 degrees east. So you're from the origin, you're going on the north line, and then you go 40 degrees east of the north line. The second one, north 60 degrees west. So on the north line, you go 60 degrees west of the north line, right? And then this next one is due south 30 degrees west. So if you go south first, and then 30 degrees off of the south line, and then south 75 degrees east. So off the south line, 75 degrees to the east, okay? So a ship is sailing due west at 20 miles per hour. Records the bearing of an oil rig at 55.4 degrees west. So north, on the north line, and then we create an angle that's 55.4 degrees west, and that's pointing us straight to this oil rig. An hour and a half later, the bearing of the same rig is now north 66.8 degrees east, right? So we've essentially sailed past it, we sailed past it. So how far is the ship from the oil rig? So if we're traveling at 20 miles per hour, and we travel for 1.5 hours, so you can get that distance from there, right? 30 miles for that baseline. Then we can use the law of sines and triangles to calculate everything. How close did the ship pass? Okay. We don't have our image. Okay. So we have our oil rig here, right? We have our baseline where the ship is sailing. Okay. So we have our due north. Let me think. Now that first reading, so the ship is here, right? So our boat, I'm just going to do something like this. It's heading due west at 20 miles per hour. So it's heading in this direction at 20 miles per hour, right? Now the first reading, this is our oil rig. I don't know how to draw an oil rig. Something like this, like this, like this, like this. And we'll do some smoke, right? It's an oil rig. And we're going to do a couple of readings. This is the second reading from here. The first reading is here. Okay. So for that first reading, it says off the north line, 55.4 degrees west, right? So if this is the north line, style. They said it went 55.4 degrees west. So 55.4 degrees west is this angle here. Okay. And then the ship, again, 20 miles per hour. It traveled for 1.5 hours. Or 90 minutes, did it say? Hour and a half, okay. So now the ship is over here at this other point. Let me duplicate this. And it gets a reading measure of 66.8 degrees east. So this angle is 66.8 degrees east of north, right? So that angle, okay? So it looks like we need to find the, we can basically label this triangle. We need to find the complementary angles for each of those. Like, let's call this angle A, angle B, and we'll call this angle C, okay? So let's go ahead and find the complementary angles. Hey, Google, what's 90 minus 66.8?
90 minus 66.8 is 23.2.
Okay. Hey, Google, what's 90 minus 55.4?
90 minus 55.4 is 34.6.
Okay. So then, okay, let's see. What are we trying to find here? How far is the ship from the oil rig the second time? So basically they're asking us to solve for side B, right? So solve for side B. Okay. Okay. So we can find this side C down here, right? If they're traveling 20 miles per hour times 1.5 hours, it should be 30 miles, right? There should be 30 miles down here. 1.5 times 20. Okay. So if we were going to use the law of sines to find side B, okay. So then side B in this context would be what? B over the sine of B. So we would have what? The sine of that 34.6 equals, okay, so it looks like we need angle C. We can find that. So then times 30. So this guy times 30 miles over, we need that angle, right? So we'll do 180 minus the 23 minus the 34. Hey, Google, what's 180 minus 23.2 minus 34.6?
180 minus 23.2 minus 34.6 is 122.2.
Okay. So at that second reading, this calculation should give us the distance of the boat from the oil rig at the second reading. Okay. Clear. So we'll do 30 times, we don't need all that, 30 times the sine of 34.6. Let me make sure I'm in degrees, okay? Divided by the sine 122.2. Okay. The unit should be in miles. So we'll say 20.1 miles approximately. 20.1 miles. Okay, I think that's a reasonable result. So that was for question A. And then for question B, how close did the ship pass to the oil rig? In other words, they're asking for this altitude here. So in our triangle, that would be H. Okay. Okay. Opposite over hypotenuse. So we can use our result. We can use that distance, that result we got for side B. So the sine of A should be h over. Okay, so we're working on this part. The sine of angle A should be h over B. So then h is going to be equal to B times the sine of A. So B times the sine of angle A. So then h equals B. We got that. So now it's an approximation because we're using rounded results. 20.1, let me clean it up just a little bit. 20.1 miles times the sine of angle A of that 23.2 degrees. So we're going to say that result times the sine 23.2. So about 7.9 miles or 8 miles. Okay. All right, so these are the results that we got. Let's compare this to our prepared notes. So here's a drawing just in context of what we experienced. Okay, I think we got all those similar parts. 20 miles from the oil rig when the second bearing was taken, and that's pretty much what we got. And then 7.9. So the ship passes within 7.9 miles of the oil rig. Same thing we got. We're almost there. Let's keep going. Okay. So now we've explored the law of sines, right? Namely that we've applied the law of sines through several cases, and then we explored the whole ambiguous case, the whole side-side angle thing, and how to address that. That's going to take practice and exposure. So then we also have this notion of the law of cosines. So in a triangle ABC with sides of length A, B, and C, A squared equals B squared plus C squared minus 2BC cosine of A. So on and so on and so on. These are the law of cosines. All right. Okay. So in words, the square of any side of a triangle is equal to the sum of the squares of the length of the other two sides, less twice the product of the lengths of the other sides and the cosine of their included angle. Okay. Anyway, so law of cosines, you just got to use the proper formula for whatever it is you're trying to do. I feel like this tends to come in play like when we try to use the law of sines and we're not able to. And so then we'll try the law of cosines, okay? The following diagrams illustrate the law of cosines, okay? Angle A is an acute angle, okay? Our x versus our y. So C is this point B cosine of A. Cosine of A, okay? Adjacent over hypotenuse, and then the y coordinate is B sine of A. That's fine. Oh, okay. So we have this triangle ABC, right? So that's like triangle, like what we've been doing. If we put A at the origin, B is this point, and C is another point up here. And then if we consider the altitude, right, we're focused on this point C. So we have some x versus some y. So then if we were to consider the cosine of A, that would be adjacent over hypotenuse. So then our x coordinate would be B times the cosine of A. That's where this comes from. And then our y coordinate would be what? B times the sine of A. Similar way how we found x, okay? This is when our angle A is acute. If our angle A is obtuse, let's see, right? We still have our x versus our y. Cosine of A. Adjacent over hypotenuse. When we did it over here, it was x over b, x. Okay. Cosine of this angle would be x over b. So then x would be b cosine of angle A, and then b sine of angle A. Okay. Okay, and this is when angle A is an obtuse angle. Okay, so we have those components. There's more. Right, let me see something. So A squared if we're using Pythagorean theorem, so we have a right triangle. What about there? I'm just trying to make a connection. I know there's something simple, something with the Pythagorean theorem I'm missing. Let me see. Minus 2b cosine of a, 2bc cosine of a. If we wanted this guy, a squared plus b squared equals c squared. Okay, let's see if we do a Pythagorean theorem, right? A squared plus b squared equals c squared. So we have our y, which is right here, right? So that's squared. What about this guy here? We're gonna have to subtract. Okay, if we let's do b squared first. Let's just see if we can get that one. So say we wanted to. Oh no, all my batteries are just dwindling. Okay, so if we said a squared plus b squared equals c squared, so if we squared this guy plus this guy squared equals this squared, right? Let me see. If we square this, we can factor out the b squared. We're going to have a 1, because sine squared plus cosine is a squared is a 1. So we'll have b squared. Is that helping us? I don't think that's helping us. There's something more I got to think about as far as that derivation. That was just me playing around. I didn't get it all the way right now. I'm kind of pressed for time with my battery dwindling and everything dying. And we're almost to the end, so I had to think about the derivation for the law of cosines a little bit later, because I've done it before. For whatever reason, it's just slipping my mind. But you know, for right now, we'll just use the formulas, and then once I remember how to process it, then we'll come back. Okay. But we can still use it though. Okay, so solve this triangle where we have this given information around each answer to the nearest tenth. Okay. Is this the side? This is not side angle, but the given angle is an acute. So side angle, we would be given, like for this instance, this would be ambiguous if we have that the given angle is 60 and we're also given the corresponding side. But notice here we're not given the corresponding side, so this isn't one of those ambiguous cases, right? So it looks like we would use the law of cosines where our given angle is acute. The C is acute. Okay. So let's start by drawing a triangle. So I'm just going to do something like this. Again, not necessarily a right triangle. Now my given angle, I'm going to put my 60 degrees here. Okay. So that means this would be side C. A and then B. Does that matter? I'm just going to put my A down here. I'm going to let this be my A. And I'll do A equals 15 inches down here. And then so that'll make this my B at 10 inches. And my angle B. Okay. Now I think if we try to do the law of sines, we don't, like, because of the orientation, we don't have enough information to use the law of sines. So then let's use the law of cosines, and let's go ahead and solve for side C, right? So if we're using the law of cosines, that should be what? C squared equals A squared plus B squared minus 2AB cosine of C. Okay. So then that should be equal to 15 squared. B is 10 squared. 2 times 15 times 10 times the cosine of 60 degrees. Okay. So then c squared, clear, 15 squared plus 100 minus 2 times 15 times 10 times the cosine. Let me just go ahead and put my multiplication. Times the cosine of 60 degrees. Let me make sure I am in degrees, okay? So for c squared, we're getting this guy, 175. Okay. Square inches. Square root, 175. Let me see. So 7. 7 times 25. So then it looks like it's 7. 7 times the square root of 5 inches. Let me check something. 7 times the square root of 5, quantity squared, we should get 175. Uh-oh. 25 times 7. Sorry. Square root of 20. Okay, I got it backwards. It's 5 times the square root of 7. I was like, why is that number not working? It's 5 times the square root of 7. Okay. So I'm glad I checked it before I went forward. 5 square root of 7. There we go. 175, okay. Solve the triangle. Okay. So what we got, angle A, angle B, angle C. Let me clear these up. So we're given angle C at 60 degrees. Okay. We also want to find side A, B, and C. We're given side B is what, 10 inches. Side A is 15 inches. Okay. So we got side C. The exact result we got was 5 times the square root of 7 inches. Okay. Then I think we can use the law of sines at this point. We can do the sine of B over B equals the sine of C over C. So then we can say what? The sine of B is going to be what? 10 times the sine of 60 over this 5 times the square root of 7, okay? And then we need to do the arc sine. Our answer should be between 0 and 90. I mean, yeah, essentially 0 to 90 based on context. Okay, let's see. Mode, okay. Let's do the arc sine. Now our numerator is 10 times the sine of 60 degrees. Let's close off our numerator divided by, I'll just do a denominator, 5 times the square root of 7. Close off my denominator and close off my arc sine. 0 to 90, okay. So we got a result, and let me do it like this. Like that, okay. So for angle B, we got a result of 40.9 degrees. And then all I'm going to do for angle A is just say 180 minus the other two. So minus that answer, minus 60, 79.1 degrees. Okay, this was for triangle ABC. Okay, and this is the result that we got. Let me get rid of this. Let me get a copy of this guy. Copy. And I just want to do a side-by-side comparison with my prepared notes. Come on. Just want to look at the final result. Is that the result? That is the result. Let's paste. Okay. 79.1 degrees, 40.9, 60, 15 inches, 10, and 5 times the root of 7 should be that. Okay. I just want to see if they did anything different than we did. Okay, so we find, let me see. Use the appropriate form in law of sines to find the side opposite the given angle. So we used the one for C. Square root of 175 was approximately 13.2 inches, which is what we got. Then we used the law of sines, and we got the same thing. So they pretty much did the same thing we did. Solve this triangle with this given information, round to the nearest tenth. Okay. Is this ambiguous case? No, this is side, side, side. Okay, let's see what we can do. So I don't know the dimensions. I'm just drawing a triangle, not necessarily acute or anything. I'm just drawing a triangle to work. Okay. So this is side, side, side. Not necessarily drawing a scale. I'm going to label this as A. I'm going to label this as my B and as C. So my side A, side C, and side B. Again, this isn't necessarily drawn to scale. So this is a 3.1. That's given. B, we got 5.4. And C, we got 7.2. Okay. So let's try what the law of cosines to find angle A. So from the law of cosines, we'll have what? A squared equals B squared. Oh no. Everything is dying. We're almost there. I'm trying to finish. Oh, we are down to the wire. I'm going to just watch that battery. A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Okay, let's plug in. Okay. So then A. So we're going to have 3.1 squared equals 5.4 squared plus 7.2 squared minus 2 times 5.4. C is 7.2 times the cosine of angle A. So we got to work this backwards to solve for that angle A. Okay, we subtract, and divide. Okay, so then ultimately we'll get cosine of angle A equals 3.1 squared minus 5.4 squared minus 7.2 squared divided by this negative 2 times 5.4 times 7.2. So then ultimately we're going to take the arc cosine of whatever that answer is, and that should be our angle A. Okay, so I'm just going to put all this in the calculator. Okay, I'm going to do my arc cosine. I'm watching my battery. I know everything is dying on me. My numerator, 3.1 squared minus 5.4 squared minus 7.2 squared. Okay, close off my numerator, divided by my denominator, negative 2 times 5.4 times 7.2. Okay, and then close off my arc cosine. Mode, we are in degrees, and push it. So for angle A, we got a result 23.6 degrees. Okay, we got that result. Okay, I think we can use the law of sines at this point. So like for instance, if we want B, okay, I'll do another color. Let's move right here. No, let's do this color. Okay, so say we want angle B, my battery. Okay, so then if we use a law of sines, the sine of B over B would equal the sine of A. So our B is 5.4. Sine of angle A we got is at 23.6. Over side A is 3.1. Okay, so that's what we want to put in the calculator. Oh, trying to wrap this up, guys. Hopefully we don't get cut off. 5.4. Nope. Where'd that 5.4 come from? That was there. Okay. Oh, come on. 5.4. Oh, shiesta. Come back. 23 point. Okay, I think that's supposed to be a 23.4. Okay. Okay. So now we're going to do 5.4 times the sine of that answer divided by 3.1. So, and then we need to do the arc sine of that answer. And so for angle B, we got approximately 43.7 degrees, okay? Okay, let me just highlight it. And then we'll just say 180 minus each of those. Come on. It's going to be a little bit skewed. 180 minus that answer minus, I'm going to write the long decimal for this other one. 23.3528 29.94. Okay. So for angle C, I'll just do another color. We got approximately 112, so approximately 113 degrees. Okay. Oh, we're about to die. Okay, I'm gonna have to abandon my microphone. Hang on. Oh. All right. Oh. All right. So I got to give my device some juice before it dies. I was trying to finish out this lecture without having to abandon my microphone, but that's how life goes. Okay. So for C, I think we got approximately 113 degrees. Okay. All right. I want to copy my results. And we'll just do a side-by-side comparison of what they got right here. Paste. So again, all the sides were given. We're going to shrink this down. Okay, so angle A, angle B, and angle C. And the sides were given, so that's why I didn't bother copying those. Okay. A, 23.4.3, that's fine. B, 43.7, and C was 113. Okay. All right. So we're going to let that be. Oh, and that was it. We were right there. Oh, no, there is one more. Okay. Solve this triangle where A, B, and C are given. Round each answer to the nearest tenth. Let me, side, side, side. Okay, so let's just do the same thing. Oh, it says no solution. Let me think. Okay, yeah, let's just proceed like we did before, right? So we're doing side, side, side. So let's just start by trying to find angle A using the law of cosines, right? So from the law of cosines, we have what? A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Okay. So that would be what? A 2 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of angle A. Okay. So then the cosine of A would be equal to this 2 squared minus 9 squared minus 5 squared divided by negative 2 times 9 times 5. Okay. So now, when we do arc cosine, remember that arc cosine is restricted to, let me do that off to the side real quick. So if we think about cosine and we have to impose a restriction in order for it to have an inverse, we have to do a restriction on the domain. For cosine, we restrict our x's to 0 to 180, right? The closed interval from 0 to 180 degrees. And our corresponding y's, okay, so this is where that has to be less than 1 comes into play. Our y's go from negative 1 to 1. So when we go to do arc cosine, again, these switch places. Okay. So I want to say if the cosine of A is larger than 1 or, is either larger than 1 or smaller than, well, if it's larger than 1, then no triangle, right? No solution. That should be the case. Let's see if that works. Right here. Okay. So our numerator, 2 squared minus 9 squared minus 5 squared. Our denominator is this negative 2 times 9 times 5. Okay. So because the cosine of A, because we can't do the inverse, it has to be between negative 1 to 1, and it's larger than 1, so then we would say no triangles possible, or 0 triangles possible. That's interesting. I don't know why I never considered that. Because it took me a while to realize that, like, when you're working with arc cosine and arc sine and all that, it helps if you identify this portion first. So then, because when we go to take the cosine of some angle, our answer is going to be between negative 1 to 1. So then when we do arc cosine, we can only do arc cosine when our x is between negative 1 to 1, right, from this discussion. So then we would say, again, 0 triangles possible. Okay, not too terribly bad. Okay, let's see the way the book articulated that. Find B, yada, yada, yada. They did B. Okay, so the cosine of B is a negative 2.6. The range of the cosine function is from negative 1 to 1. There is no angle B such that when we take the cosine of B, it's going to produce a result that's negative 2.6. So the triangle cannot exist. So zero triangles possible, right? We had a similar reasoning, right? Because we're looking for an angle. When we find the cosine of some angle, the output should be between negative 1 to 1, and our output was at 1.13 bar, right? Which is not between negative 1 to 1, so 0 triangles possible. Okay. Okay, that was, let me see if I can do this real quick. And my battery is growing, so it's not going in the proper direction. I just can't use my microphone while I do this. And I think we're good to go. So that was an adventure. A little bit, we had a little bit of... The only thing I kind of... And I've done it before, I just have to think about it a little bit more, is the derivation for the law of cosines. I just need to think about it some more. It probably using like the distance formula, right? Once we have those points labeled, let me backtrack real quick. I just want to look at it. Law of cosines, right? So say for instance, say we wanted to find side A, right? We have our B and we have our C. So if we want the distance of A, and what if we use the distance formula, the distance between 2 points? The square root of what? X of 2 minus x of 1 squared plus y sub 2 minus y sub 1 squared. I think you just use the distance formula for all of those sides. So once we've identified our point A, our point B, and our point C in this context, and then the law of cosines, I knew it was something simple. It's just in that moment I couldn't remember. But when I thought about it at the end, I was like, oh, duh. Just try using the distance formula, right? So once we identify all the points in this context, for any side that we want, if we use the distance formula, we can generate the law of cosines. I think that's what it is. I knew it was something simple, so, okay? I think we got it now. I think we got a complete set. It's a little bit dicey, but we got through there. We got all the parts, the necessary parts figured out, okay? And so with that, we're going to go ahead and end the session here. And from one beautiful mind to another, take care and peace.